Hey everyone, welcome back to another CIE A-Level Maths past paper video. Today we're going to talk about paper 1-2 from the May-June 2025 series. So let's jump into the paper. Okay, so question number 1. The diagram shows the graphs with equation y equals to f of x and y equals to g of x. Describe fully a sequence of two transformations which transforms the graph of y equals to f of x to the graph of y equals to g of x. Make clear the order in which transformations should be applied. Okay, so we can see that there are two transformations happening over here. There is a vertical stretch happening over here, like this is for example 3 units and this is 6 units. 2 to minus 8, minus 2 to minus 8, basically a stretch by 2, right, vertically, and there is a translation happening, but depending on which comes first, the answer will be different. So we can have either one first, but the final answer would be different. How? If we do the stretching first, it will be a times by f of x plus b times by g of equals to g of x. So this is stretching and this is translation. This means stretching first, then translation. Otherwise, you could have translation first, and then you can have your, we can do some other ones also, for example, P and Q. So this could mean that you were doing translation first and then stretching. And that could also transform into G of x. So basically this would mean that, as you can see, this is P times by f of x minus PQ equals to G of x. Right? Okay. So now if we do the stretching first. So if we do the stretching first, for example, all the values of y will be multiplied by 2. Right? So this value over here 3, this entire line would be coming over here. So see, the vertical distance between this line and the transformed line is 6 and 8, that is 14. So if we do this first, this would be this thing. So times by 2 for the vertical stretching and minus 14 for the translation. Similarly, if we do translation first, okay, so if we do the translation first and then the stretching, so that will require a little bit of thinking. So as you can see, this will be a similar form also, right? So this will be a similar form also. So this would mean that this is still 2 times by f of x, and this PQ, 2 times by q, is 14. So this your PQ is 14, and we determined that P is 2, right? So Q would be just 7, right? So f of x minus 7 equals to g of x. That means first we are moving every point 7 units down. So for example, this would be over here like this, and 3 units down, so somewhat like this. So somewhat like this and this, right? And then we move the units downwards. Sorry, stretching. Yes, stretching. So minus 4 will become minus 8. So that is how you can actually see, because the function itself is identical. So both sides will be identical. So the sequence, whichever sequence we make, should obviously give us the same function at the end. Right? So 2 times by f of x minus 7 is same as 2f of x minus 14. Sorry, I was right about this. Right. So vertical stretching parallel to y-axis. So vertical already means parallel to y-axis by a factor of 2 followed by translation by 0 minus 14. Over here it's a translation by 0 minus 7 followed by stretching, vertical stretching by a factor of 2. Right, and that's it for this question. Let's move on to the next one. Question number 2. Find the coordinates of the points of intersection of the curve and the line with equations this. Okay, so two ways we can handle this. Either we can substitute out x or y. In fact, you could even do 2x also. So for example, if you do 2x, you would be minus y plus 4, because when you take it on the other side. And if we do the y, you can have minus 2x plus 4, right? The entire thing, minus 2x minus 4 or minus y minus 4. Either way, whichever way suits for us. So let's try plugging it into this. So if we substitute out 2x, this would be minus y plus 4 y plus 5y squared equals to 24. But if we had substituted out y, this would become 2x plus y is basically just this minus this thing times by, so we can bring out the minus 2x plus 4 plus 5 y squared. So the square of 2x plus 4, because minus minus will become just plus, equals to 24. Now, as you can probably see this over here, this will be slightly longer because of the expansion of the square, but otherwise it's still a valid way of working. So you have minus y squared minus 4y plus 5y squared equals to 24. If we go this way, this would be minus 4x squared minus 8x plus 5 times by 4x squared, 20x squared, 2 times by 4, 8, 8 times by 2, 16, 16 times by 5 is 80x, then 16 times by 5 again is 80 equals to 24. So simplifying this, you have 5, this becomes 4y squared minus 4y minus 24 equal to 0, which can be further simplified as y squared minus y minus 6 equal to 0. Now this can be factorized easily, but let's simplify this one also. 20 minus 4 is 16x squared. 80x, this would become 72x, and 80 minus 24, 56, plus 56 equal to 0. They're all divisible by 8, so 8 times by 2, 8 times by 9, and 8 times by 7. So if we do this way, one of them is negative, one of them is plus, so just simple sum and product rule. So actually we can do this over here. So you have minus 6 y squared minus y. So it's obvious that it's going to be 3 and 2, but which one of them is negative? It's obvious, minus 3. So y minus 3, 2, y plus 2 equal to 0. This would make either 3 or y equals to minus 2. Now this will give us two different values of x from this equation, right? We figured out x from, this one, yeah, 2x is equal to minus y minus 4. So you can figure out the values of x also. But if we just simply do this one, again 2, 7 and 9. So 2 and 7 also become easy. So 2, 7. So just simply 7x plus 2x. So you have 2x plus 7 x plus 1 equal to 0. So x is either minus 7 over 2 or x is equal to minus 1. Now we plug in the values of the other one and see whether we are getting the same answer or not. So x is equal to minus y minus 4 divided by 2. So minus y minus 4 divided by 2. So this is minus 7 over 2. And this one gets us minus 2 minus 4 divided by 2. This is minus 3. Oh, sorry, no, this is already negative now, so this will become 4 minus 2, so minus 1. Yeah, so minus 2 over 2 is minus 1. And if obviously, as you can see, that we are getting the same values of x over here, so naturally this would mean that if you plug in the values in the y equation, minus 2x minus 4, you would get the same values. So you can try it and you will get the same answers. So either process, like you can start it this way, you can do it this way, either way you are getting the same answers. Alright, so the coordinates we are going to write are minus 7 over 2, 3 and minus 1, minus 2. Okay, alright, so let's move on to the next question. Okay, so question number 3. The coefficient of x raised to power 7 in the expansion of this is 1280. Find the value of constant p. Okay, so according to the binomial expansion rule over here, is that it's going to be the sum from 0 to 5. No, sorry, not x is equal to 0. Let's call it a equals to 0 to 5. This is going to be 5c0 px squared 0. Sorry, a. This is also a over here, and then 4 over px. Also 5 minus a. Okay, now we need to figure out where this coefficient of x raised to power 7 comes in. Okay, so this means that you have x raised to power 2a squared raised to power a and plus x raised to power 5 minus a, and this is equal to x raised to power 7. So this means that 2a plus 5 minus a equals to 7. So a is equal to 7 minus 5, 2. So that means it's the second term in this order. So therefore it would be or n is equal to 2, whatever the term number is. This is going to be 5c2 times by p squared, like obviously this a is 2 now, so x raised to power 4 times by 4 over p, 5 minus 2 is 3, and x cubed also. Right, this is equal to 1280 x raised to power 7. Right, so we can cancel out this x raised to power 7 because that's not what we're looking for. So therefore this is 5c2 10 times by p squared times by 4 cubed 64, p cubed equals to 1280. So p squared, p cubed cancel, so only p is left. So therefore p is 640 divided by 1280. So 64 divided by 128 is 1 over 2. Right. And that's about it. Let's move on to the next question. Question number 4. A point P is moving along the curve with the equation y equals to this in such a way that the x-coordinate of P is increasing at a constant rate of 5 units per second. So the dx over dt is 5 units per second. Okay, find the rate at which y-coordinate of P is changing when x is equal to 9. Okay, so first off we need the dy by dx, then dy by dt can be found by chain rule. So dy by dx is 3 over 2 comes down. This becomes 1 over 2. This becomes minus 12. We need it at x is equal to 9, right? So dy by dx at x is equal to 9. So you have, okay, so 3 over 2 times by a, 9 square root is just 3. So just 9 over 2a minus 12. Okay. For dy by dt, we need the dy by dx times by dx over dt. This is 9 over 2a minus 12 times by 5. So 45 over 2a minus 60. Okay. Given that the curve has a minimum point when x is equal to 1 over 4, find the value of a. Okay. So dy by dx at minimum point. So dy by dx at x is equal to 1 over 4, which is, again, the function was this thing, 3 over 2a x raised to power 1 over 2 minus 12. Wait, sorry, minus 12, right? Yeah, only minus 12. Just to be sure, yes, okay. Equal to 0. 1 over 4 square root is just 1 over 2. So this will become 3 over 4a minus 12 equal to 0. So 3 by 4 of a is equal to 12, and therefore a would be 12 times by 4 over 3. So it's obviously clear, 3 times by 4, and this is 60. Right. Okay, let's move on to the next question. Question number 5. The equation of a curve is y equals to 4 cos 2x plus 3. This state the greatest and least possible values of y. Okay. So the cos 2x, goes from -1 to 1. The 2x doesn't affect the minimum or maximum. When we multiply the 4 with it, this becomes 4 and -4. When you add 3 in this becomes 4 plus 3 and -4 plus 3. So this becomes -1 from and 7. Okay, so that's basically the least and the maximum value. Okay, now sketch the curve. Okay, so the maximum value is 7. We have to keep a little bit of that. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Okay, so 7 and -1. So if this is 7, so this would be -1. Okay, and the value, the mean position, is 3. So if we do this 2, 4, 6, 8, so in between this is our mean position. Okay, so this is our 7, this is -1, this is 3. Okay, now furthermore, we know the cos 2x decreases the period by 2. So this becomes 360 divided by 2, just simply 180, or pi radians. Okay, so at pi you will have a 1 full wave of the cosine. So normally this would go this way. So it would be at minimum over here, it would be passing over this, this, and this. Okay, so okay, so that's it. Okay, right. Hence determine the number of solutions of the equation this equals to 2x minus 1. So that means we gently need to sketch this. So 2x minus 1, so 1 point is -1 itself. So y equals to 2x minus 1. For example, where it crosses pi or half a pi. So y equals to 2 pi minus 1. So 2 pi minus 1, is 5 point that. So 5.2, right. So this is 3, this is 4, this is 5. So roughly somewhere over here. So if we draw a line, sketch a line, so somewhat like this. So we have 1, 2, and 3. So 3 solutions. 3 points of intersection correspond to 3 solutions. 3 solutions. Right, okay, let's move on to the next question. Question number 6. The diagram shows the curve with equation y equals to 9 over 5x plus 4, 1 over 2, and the line y is equal to 6 minus 3x. The line and the curve intersect at point P, which has the y coordinate 3. Find the area of the shaded region. Okay, so up until this point, notice that the line is greater than the curve, and it's just the area under the curve up until this and this thing. So we basically need to figure out what the x coordinate of this point is. So y is equal to 3, 6 minus 3x, so 3x is equal to 6 minus 3, so x is just simply equal to 1. And we would also need to figure out where y becomes equal to 0, so 0 is equal to 6 minus 3x, so x is basically just 2. Right? So from 0 to 1 it's the area under the curve, and from 1 to 2 it's the area under the line. Right? So area of shaded region is from 0 to 1, it's the area under 9, 5x plus 4 minus 1 over 2 dx, and plus from 1 to 2, 6 minus 3x dx. Okay, so when we integrate this thing, you get 9, 5x plus 4, power becomes 1 over 2, divided by 1 over 2, times by 5, the derivative of 5x plus 4, from 0 to 1, plus 6x minus 3x squared over 2, from 1 to 2. You could just simply do the half times by 3 times by 1 also. Okay, so we should be able to get the same answer, right? Okay, so 9 divided by 5 over 2, so this would become just simply that. So if you want to check that, so 9 divided by 0.5 times by 5, this is 18 over 5. So as predicted, so 18 over 5 times by 5x plus 4, so that means 5 plus 4 square root minus 0 plus 4, 1 over 2, plus a right, okay, then you have 6 times by 2, 12, minus 2 squared is 4, 3 times by 4, 12, 12 divided by 2, 6, minus 6, and then 3 by 2. Okay, alright. So 18 over 5, 5 plus 4 is just 9, 9 square root is just 3, and 4 square root is just 2, plus, as you can see, 12 minus 6 is just 0, 12 minus 6 plus 3 by 2, so this thing just cancels out, only 3 by 2 left, and that's exactly what we would have just gotten by doing half times by 3 and 1, 3 by 2. Either way, that's fine, we got the same thing. So this is just 18 over 5 plus 3 by 2, so this becomes 10, 36 plus 15, so 51 over 10, or 5.1. Okay, so let's move on to the next question. Question number 7. Prove the identity tan theta plus 7 divided by tan squared theta minus 3 equals to or identical to sin theta cos theta plus 7 cos squared theta. Right, okay, so wait a second, let's see what this means. Okay, so if we make tan theta into sin theta over cos theta, we might be able to do this faster. However, both ways should be easily doable. Like both sides could be easily shown to be equal to. So okay, so for example, we expand the left hand side. Since tan theta is equal to sin theta over cos theta, so this would become sin theta over cos theta plus 7 divided by sin squared theta over cos squared theta minus 3 simplifies to sin theta plus 7 cos of theta divided by cos theta divided by sin squared theta minus 3 cos squared theta divided by cos squared. Right? So this is now just simple division. Sin theta plus 7 cos theta divided by sin squared theta, minus 3 cos squared theta times by cos squared theta over theta. Right, so one of them can cancel out, so you multiply this. On the numerator, this would become sin theta cos theta plus 7 cos squared theta divided by this is equal to 1 minus cos theta, so this becomes 1 minus 4 cos squared theta. Okay, so this is hence shown that left hand side is identical to right hand side. Okay, if you want to do the right hand side, I think you can just basically reverse the process. Right, okay, let's see the B part. Hence solve the equation. This equals to 5 over tan theta. So this is, what was it? Tan theta plus 7 divided by tan squared theta minus 3, or was it plus 3? Equals to 5 over tan theta. Right, so when we do the cross multiplication, this would become tan squared theta plus 7 tan theta equals to 5 tan squared theta minus 15. So bring everything on one side. This would be 5 minus 1, 4 tan squared theta minus 7 tan theta minus 15. So this is a quadratic equation. So let's see if we can get factors for this. Okay, so 3 and 5, 2 and 2. So no. But if you do 12 and 5, yes, so 12 and 5 definitely can get us that, but if this is negative, right, okay, so this is tan theta minus 3 4 tan theta plus 5 equal to 0. This would mean that either tan theta is equal to 3 or tan theta is equal to minus 5 over 4. Okay, so from 0 to 180 degrees. Okay, so if we do this with the cos diagram, tan is positive in this one and negative in this one. Okay, so tan is equal to 3, tan inverse of 3. So 71.6 degrees and minus 5 over 4. Oh, sorry. Minus 51. So you do plus 180. 128. Okay, so basically this would come right over here. So 128.7. Had you done this with the help of a graph, 0 to 180 would be going this way, right? So the 3 would be over here, and minus 5 over 4, this would be over here, greater than pi by 2. Sorry, one of them would be less than pi by 2, the other one would be greater than pi by 2. Okay, let's move on to the next question. Question number 8. The diagram shows the circle with equation this, and the line y is equal to minus 2. The line intersects the circle at points A, B. Find the coordinates A, B, and C. Okay, so for A and B, we just have to plug in y equals to minus 2. And for the center, you see this would be, since this is a horizontal line, midpoint of this, so the simple just circle theorem, midpoint of this is basically passing through the center line, right? Okay, so at least this would get us the x coordinate. Similarly, if you want to do it this way, you connect this chord and this chord, the perpendicular to this would also be passing through center. So the perpendiculars of chords, perpendicular bisectors of chords passes through the center. So there are multiple ways to handle this. I think the easiest one to find the center is to just complete the squares for this. However, for the A and B, it's easy. So you just plug in y is equal to minus 2. So you have x squared plus minus 2 whole squared minus 14 minus 2. No. X. Okay. Plus 8 minus 2 plus 36 equal to 0. This is x squared plus 4 minus 14x minus 16 plus 36 equal to 0. This becomes x squared minus 14x. So 4 minus 16 plus 36, 24. So as you can see, it's the combination of 12 and 2 that can get us this thing. So no. Yeah, so 24 and then minus 14. So minus 12x minus 2x. Okay, so this would be x minus 12, x minus 2 equal to 0. So either x is equal to 2 or x is equal to 12. So A is before 4, right? Yeah, so 2 minus 2, and b is 12 minus 2. Right. Now for the center, x squared minus 14x, y squared plus 8y equals to minus 36. Okay, now we complete the squares for this. This would be x squared minus 14x. 14 divided by 2 is 7. So 7 squared minus 7 squared plus y squared plus 8y. 8 divided by 2 is 4 minus 4 squared minus 36. So this becomes x minus 7 whole squared plus y plus 4 whole squared, and this is minus 36 plus 49 plus 16. So minus 36 plus 49 plus 16 is 29. Okay. So center C is 7 minus 4. Okay, alright. Find the angle ACB in radians. Okay, so ACB in radians. Okay, so the distance between A and B is 10, and from this to this, this is minus 2 and this is minus 4, so this distance is just 2, right? So basically we can use the straight line, the right angle geometry, or right angle trigonometry, sorry. 5 and 2, we can find out the angle. So this way this would be opposite over adjacent, so tan theta opposite over adjacent, so 2 times by that angle, right? So whatever this comes out, it would be that. So we have this thing. So 5, 2, theta. So tan inverse of 5 over 2. So tan inverse of 2.5 is 68.199, and angle ACB is equal to 2 times by tan inverse of 5 over 2. So you just simply multiply this by 2, you get 136. 4. The chord AB divides the circle in 2 segments. Find the area of the larger segment. Okay, so what we can do is we can find out the area of this sector first and then multiply by the area of this triangle. Okay, so now we know the angle. Wait a second. Oh, sorry. We have to give it in radians. Sorry, I just completely forgot. So this is going to be 3.8 radians. Okay, right. This was a good. Okay, right. And correct to 3 significant figures. Okay, right. So if this is this thing, we can figure out 2 pi minus that also. So 2 pi minus this value. Okay, so area of segment is going to be area of sector plus the area of triangle. So area of sector would be half r squared is just 29. We found this over here, right? 29. And then the theta in radians is this 2 pi minus 2 tan inverse of 5 over 2 plus the area of the triangle, which is half AB sine theta, right? Okay. Half, again r squared, sine of the same angle, ACB. Okay, so right, so this times by 29 divided by 2 is 56.58778 plus we get 29 divided by 2 times by sine of tan inverse of 5 over 2 times by 2. So yeah, basically that's what we get. Right, 10. Okay, so this would be just 66.6. Right, okay, let's move on to the next question. Okay, so question number 9. The equation of a curve is such that d squared y over dx squared is minus 24 over x cubed. It is given that the curve has a stationary point at minus 2, 19. Find an expression for dy by dx. Okay, so when you integrate this thing, you will get d squared y dx squared dx. So when we integrate this, you basically have minus 24x raised to power minus 3. So this becomes minus 24 minus 2 divided by minus 2 plus c. So this becomes 12 over x squared plus c. So at minus 2, your dy by dx is equal to 0. So we know that x is equal to at x is equal to minus 2, dy by dx is 0. So this becomes 12 over minus 2 squared 4 plus c equal to 0. 4 times by 3. So c is therefore minus 3. So therefore the dy by dx would be 12 over x squared minus 3. Okay. Find the x coordinate of the other stationary point of the curve and determine the nature of this stationary point. Okay, so we have dy by dx equals to 12 over x squared minus 3x squared equal to 0. Right, so this would mean that you have 3x squared minus 12 equal to 0, 3x squared minus 4 equal to 0. divided by 3, this would just become x squared minus 4 equal to 0. This is difference of squares. X plus 2, x minus 2 equal to 0. So either x is equal to minus 2 or x is equal to plus 2. So therefore x is equal to plus 2. We already had minus 2 and now we have plus 2. Okay, now we need the nature. For this we would need the d squared y double derivative. X is equal to 2. So you have minus 24 over x cubed. So minus 24 over 8, which is minus 3. So this means that this is negative. Which means that this is a maximum. Find the equation of the curve. Okay. Right. So we now finally need to integrate the dy by dx. So 12x minus 2 plus 3. Oh, sorry, minus 3. Minus 3, right? Yeah, minus 3 dx, and we know minus 2, 19 is one point on the curve. Okay. So this would be 12x minus 1 minus 1 minus 3x plus c. This becomes minus 12 over x minus 3x plus c. So at x is equal to minus 2, y equals to 19. So 19 is equal to minus 12 over minus 2 minus 3 minus 2 plus c. So this is just simply 6. 6 plus 6, 12 plus c, 19. So therefore c is 19 minus 12, just 7. So therefore y is equal to minus 12 over x minus 3x plus 7. Okay. Find the equation of the normal to the curve at the point where dy by dx is minus 9 over 4 and x is positive. Express your answer in the form this. Okay, so first off, we need to figure out the x coordinate at this thing. Okay, so dy by dx is this thing, 12 over x squared minus 3. Minus 9 over 4. This becomes 4 times by 12, 48. 4 times by 3, 12. Minus 9x squared. So this would become 12 minus 9, 3x squared equals to 48. Or we could have just simply done 48 minus 12 plus 9, also 3. This would have been the same thing. However, as you can see, this is still divisible by 3, so this becomes this. And 48 divided by 3 is 16. And once again, you see this is x is equal to plus minus 4. Sorry, 2. Sorry. Yeah, 4, sorry. Yes, x minus 4, x plus 4. Right? And x is positive, so therefore x is 4. Okay? So at x is equal to 4, dy by dx is minus 9 over 4, so we need the value of y. Minus 12 over 4 minus 3 times by 4 plus 7. So 4 times by 3 minus 3 minus 12 minus 15 plus 7 minus 8. Okay. So y minus y1, mx minus x1. Right, so gradient of the normal is going to be the opposite or negative reciprocal of minus 9 over 4. So y minus 8 equals to 4 over 9. X minus 4, we cross multiply, 9y, 9 times by 8, 72. 4x minus 16. This becomes 9y minus 4x, 72 plus 16, 88, equal to 0. So this is your equation of normal. Right? Okay, let's move on to the next question. Question number 10. The first, second, and third terms of an arithmetic progression are this. Right. Arithmetic progressions, that means the common difference is the same. So k squared minus 4k is equal to 8k minus k squared. So this would mean that k squared becomes 2k squared, and minus 12k equal to 0. This transforms into k squared minus 6k equal to 0. So either k minus 6. So either k is equal to 0 or k is equal to 6. Obviously, since it's a non-zero constant, so we will select this, cancel this and select this. So therefore k is equal to 6. Okay. Find the sum of the first 20 terms of the progression. Okay. So a is equal to 4k, right? So 4 times by 6, 24, and common difference, k squared minus 4k. So 6 squared, 36, 4 times by 6, 24. So this is 12 basically, right? Okay. Right. Okay. So S20, 20 over 2. Basically, it's n over 2, 2a plus n minus 1 d. Actually, I think we should have written over here 2a plus n minus 1 d. So this would be 20 over 2. 2 times by a, 48, plus 19 times by d, which is 12. So 48 plus 19 times by 12 times by 10, this is 2760. Okay. The fourth and the sixth terms of a geometric progression are 36 and 6. Common ratio of the progression is positive, but since the values are decreasing, that means it's less than 1. Find the sum to infinity of the progression. Give your answer in the form right. Okay. So fourth is AR3, 36, and the sixth is AR raised to power 5 is 6. Okay. So if we do this, a raised to power 5 over a raised to power cubed, this is 6 over 36. As you can see, a and a can be get cancelled. You have r squared 1 over 6. This means that r is the 1 over square root of 6 or square root 6 over 6. Okay, alright, so sum to infinity, we also need the a. So this is a, 36 divided by r cubed So 1 over 6 times by under root 6 over 6. So 36, 6 times by 36. So 36 times by 36, 1296, root 6 over 6. Okay, this is your A. Okay, so sum to infinity is A over 1 minus R. So A is 1296 root 6 over 6, and 1 minus R is 1 minus root 6 over 6. Okay, alright, let's simplify. So this becomes 1296 root 6 over 6 divided by 6 minus root 6 over 6. So these two will cancel out. You are left with alright. So 1296 root 6, 6 minus root 6. Okay, but I think we needed it in another form. Okay, so in this form there's only one third over here. Okay, alright. So basically what we can do is we can multiply the numerator by 6 and denominator by 6. So this would become 1296 times by 6, and this would become 6 root 6 minus 6, right? So obviously now, as you can see there, you can cancel out the 6 common factor. So actually wait, sorry, so 1296 times by 6 divided by 6 times by under root 6 minus 1. So now you can cancel out the 6 and 6. Therefore, you get 1296 divided by root 6 minus 1. Right, okay, let's move on. Question number 11. Express x squared plus 4x plus 2 in the form this. This is easy, so we need to square this thing. So x squared plus 4x plus 4 minus 4 plus 2. This would be x plus 2 whole squared minus 2. Right? Okay. The functions f and g are defined as following. Okay, so remember that whenever we have to take the inverse of f of x, a quadratic function, we can only do this using the completed square form, and it will only be half of that. So this x is equal to minus 2 is the line of symmetry, as you can see this over here. So basically, instead of having the full thing, you have basically just the half of it. So we basically just have this thing. So this is easy to take the inverse off. Right, okay. Minus 2. Okay. So in this case, alright, okay, never mind. Okay. We'll see this. So f of x equals to y equals to x plus 2 whole squared minus 2. So when you take this, so x plus 2 whole squared equals to y plus 2. Take the square root on both sides, you get x plus 2 plus minus square root of y plus 2. And then you have x is equal to minus 2 plus minus y plus 2, right? But we can't have it both ways, right? So in the original function, the range is greater than minus 2. right? So the range is also -2. So this would mean that we need the domain, both the domain, this would become the range of this. So f inverse of x would be less than -2. So basically we need the minus sign. So -2 minus y plus 2. So basically you will get the answer. F inverse of x equals to -2 minus square root of x plus 2. And if they haven't asked for the range or domain, we can say that f inverse, no, where x is less than, greater than -2. Okay, alright. Find an expression for gf inverse of x. Okay. So first we can find out gf, and then we can take the inverse, or you can do the f inverse times by, f inverse of g of x, g inverse of x. I think gf would be, let's see which one of them is slightly easy. Okay, never mind. So this is -x minus 4, so this would be x squared minus 4x minus 2 minus 4. Okay, so this becomes minus x squared minus 4x minus 6, or minus x squared plus 4x plus 6. Right, okay. We need the gf inverse. Okay, so let's call this y equals to minus wait, I think it would have been easy, because we need to take the we have to complete the square for this one. So what if we had done this thing, g inverse of x? So if gx is minus x minus 4, this is your y equals to, y equals to minus x minus 4, so this would become x is equal to minus y minus 4. Right, so g inverse of x is minus x minus 4 also. So if we do this, g inverse of x, we had f inverse minus 2 minus root x, root x plus 2, so this is minus x minus 4 plus 2, so this would become minus 2 minus, we can't have this, minus x minus 4, okay, but the x value has to be chosen, the domain has to be chosen specifically. Alright, so that's about it for this paper. I hope you enjoyed solving this paper with me. If you have any questions, confusions, or doubts, feel free to reach out in the comments. If you'd like some one-on-one coaching for May-June 2026 exams, also feel free to reach out using the links and the numbers given. If you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates. Until the next video, take care, bye-bye.